In the last episode, I showed you that perspective convergence geometry works in every orientation, 45 degrees, sideways, upside down, and that a curved surface would break that geometry the moment you rotate the image. But it doesn't break, which means that what you're observing is a property of your vision, not the surface. Now, I want to show you 3 things that people use as proof of curvature, and why that same optical geometry explains all of them. If you go into a gymnasium, or in this example there's a track, you place the camera on the floor on one end of the court, you have someone walk away from it toward the other end, where the court is level, perfectly flat, verified flat, nobody disputes that, and watch what happens. A horizon forms a short distance away. Because the camera is so close to the ground, the vanishing point is very near to the observer. As the person walks away beyond that horizon, they start disappearing into the vanishing point from the bottom up, feet first, then legs, then body. The head stays visible the longest because it's highest above the convergence point. No curve, verified flat surface, bottom disappears first. That's your controlled experiment. It's not even up for debate. Anybody can do it with a camera and a flat floor surface. Now, take that to the water. A boat is sitting at a distance. You're standing on a beach, even just 6 feet above sea level. The waterline is already below your eye level. The mast of the boat is above your eye level. The boat is far enough away that the entire boat is essentially at the vanishing point of your receiver, beyond the horizon. The waterline gets there first because it's closest to the horizon line. The hull compresses into the vanishing point before the mast does. The bottom disappears first, every time. This is predicted on a flat plane. If that disappearance was due to physical curvature, the boat would visibly be tilting away from you, bow and stern angling downward over the curve. The boat sits perfectly flat and parallel to your line of sight. What's actually happening geometrically is you're 6 feet above the plane. The boat is 30 feet tall. The bottom has 6 feet of angular distance to travel to reach your vanishing point. The top has 24 feet. The bottom will get there faster. The whole boat is converging into itself from both ends simultaneously towards your eye level. Bottom rising up to meet it, top descending down to meet it. Just like the railroad tracks compress from both sides towards the center. It's the same geometry, just rotated. Curvature requires tilt. There is none. And that distance couldn't create a tilt anyways, but in order to get that much curvature, you would need to have a tilt. So it simultaneously just doesn't make sense. Now apply the same mechanism to the sun. Watch it descend towards the horizon. The entire time it's moving, it's converging towards the vanishing point. It's also higher in elevation and further away than the optical horizon. So when it reaches that convergence point, it disappears exactly the same way the boat does, bottom first. The bottom edge hits the horizon line before the top does. Then the rest follows. I know it sounds so simple. It's not a physical drop below a curve. That's the convergence completing itself. The same process that was happening the entire descent, just finishing. Now, go up in elevation after the sun disappears, it will rise back into view. If it physically dropped below a curve, your elevation couldn't retrieve it, but it does come back because it never went anywhere. It merged into the vanishing point at your eye level based on your height. Change your position, change your height, change the vanishing point. The boat, the person in the gym, the person on the track, the coin on the table, the sun, all different observations, but the same mechanism. Every single one consistent with perspective convergence to the vanishing point. So I'm not telling you the boat doesn't disappear bottom first. It does. I'm not telling you the sun doesn't appear to sink below the horizon. It does. But all that's predicted on a flat plane.